Hi, everyone. Thank you for joining us this evening. My name is Mike Gurney. I'm with Eagle's Environmental Support Division. I'm going to take just a couple minutes here and run through a few housekeeping slides and then hand it off to the experts to talk about the Wickes, TCE, Plume in Antrim County. Just a couple quick things, like I said. Number one, all lines are going to be muted during this webinar. We will have a chance for a question and answer. I'll run through that, but during the presentations, we will keep all the lines muted. And we are recording this webinar, so you will get a recording copy emailed to you, and it will be available on our website sometime after today. So hopefully by the end of this week even, we'll have that all fired up for you. As I said, lines are muted, so please, if you have questions throughout the presentations, the Q&A box at the bottom of Zoom, you can type in your questions and we will read through those. Hopefully at the end of the meeting tonight, we'll have a chance to go through all of the questions that are submitted and discuss those. At the same time, at the end of the meeting, if you would like to raise your hand and ask your question, feel free to do that. You can do that by clicking the raise hand button at the bottom of your screen. If you're on the phone, you can hit the pound or hash sign and then the number 2 to raise your hand. So again, feel free throughout the evening to type in your questions, and we'll get to those as we can through the question and answer portion. And again, if you would like to ask the question yourself, feel free to just raise your hand or hit pound or the hash sign and then the number 2. So with that, I'm going to stop talking and stop sharing my screen and hand the microphone over to Janice Adams, who's the Eagle RRD project manager. And she'll get us started here this evening. Janice, you're on mute.
How's that?
Much better.
Wonderful, thank you. Hello, everyone. Thank you for joining us tonight as we have an update on the Wickes manufactured trichloroethylene TCE plume in Antrim County. I'm Janice Adams, and I'm a geologist with Eagle out of Remediation Redevelopment Division out of our Gaylord office. Tonight we'll be having presentations on the update information on the Wickes TCE plume and also on the extension of municipal water into the Summit Village Association. Eagle has secured $3.8 million for this project, and construction is hopefully begin in a couple of months. It is extremely important that municipal water be extended in this area. During the presentations tonight, we'll be able to show you the reasons to that. Eagle has been working with the Summit Village Association throughout this process, and they have granted us access to be able to put some additional monitoring wells in the association. And we hope to work with them in the future to be able to secure a partnership so that we can grant access to extend municipal water into this area so we can provide clean, safe drinking water to everybody. The first presentation tonight will be by Mankowski, a Woods group of Traverse City. And the second presentation will be by Performance Engineering of Charlevoix. Thanks again for joining us. And Len, you can begin.
All right, thanks, Janice. Mike, you want to spool up the presentation? All right.
How is that?
Perfect. So
excellent.
Everyone can see it. We are going to, today I'm happy to talk to you. My name's Len Mankowski. I've been active on the Wickes project since I joined Wood in 2007. Of course, back then we were known as MacTech, and many of you may know of us as AMEC. And we still work for the state as AMEC. So just as a point of reference, you may see a lot of reports from Eagle that are addressed by AMEC. That's us. And yeah, so I've been active at the Wickes site since 2007, both in the field and in the office, looking at geologic data, hydrogeologic data, geophysical data that we've collected from the site. And all of that we roll in as we collect new data into a conceptual site model. So tonight we're gonna tend to look at all of that. If you can go to the next slide, Mike. So again, this is the Wickes manufacturing trichloroethylene plume, and trichloroethylene is a mouthful, so you're gonna tend to hear me say TCE more often than not. You can see the map. This plume originates in Mansalona, and the blue arrows show the general progression of the plume as it moves to the northwest and west from the site. It moves past Shush Mountain, past the Cedar River well field, and is currently heading in a trajectory that takes it towards Shanty Creek to the west, the actual Shanty Creek. We also have a component of the plume that moves to and vents into or discharges groundwater, impacted groundwater discharges to the Cedar River. And when I refer to the plume, I'm referring to TCE impacts in groundwater and kind of, how we define that. And we'll show you that. And you can see off to the side at the right in the upper right-hand corner, a photo of the former manufacturing plant where TCE was released in Manzalona. Many of us probably know of that as the Dura manufacturing plant, but it went by several names, and we'll talk about those. The contamination that was released was well before the era that Dura operated the manufacturing facility there. Can we go to the next slide? So some things that we're going to cover tonight, I want to give you a general overview of what TCE is and some metrics so that we can understand risks, because the risks change depending on whether you're looking at TCE in a river or TCE in your drinking water, or maybe TCE in the soil vapors that occur kind of naturally below the ground as that TCE can move from groundwater into that zone. We'll roll that together into a conceptual site model and look at the plume understanding. We'll give you a general sense of the plume because it's a little bit complicated. When you see that green zone off to the right, we've got to understand that green zone changes depending on what depth you're looking at in terms of whether you're looking at a shallow water bearing zone or the intermediate or an even deeper water bearing zone. So there's some significant complexity at the site. We'll try to talk through that. And then we'll look at, kind of specific pathways of concern where people could potentially come in contact with TCE related impacts from the site. And those include soil vapor. Those include surface water like the Cedar River, and perhaps most significantly drinking water in terms of the extent of the plume. And all of that then wraps into, so what are you doing about it? And really the process that the state is engaged in is expanding the water line to make sure that folks are not getting impacted in their drinking water on the day-to-day. Can we go to the next slide? So what is TCE? It kind of goes by a couple of different names. It's trichloroethylene. A lot of times you'll hear of it as trichloroethene, which is a little easier to say. But the big thing is that TCE is a man-made solvent. It's a synthetic. It's something that doesn't occur naturally. And that has some significance for how it behaves in the subsurface once it gets down there. It was used especially in industrial processes for things like metals cleaning and degreasing. It was also used in other processes, sometimes in dry cleaning, some other aspects. But it was heavily used between 1920 and 1970, roughly in that era. And it is still used today on a very limited basis, because of its toxicity and dangers that it poses. It's really been phased out and is not used nearly as broadly as it was. But it is still used on a limited basis in some locations and in some manufacturing processes today. Couple of things to know about TCE. It's volatile, meaning that it can move from a liquid phase into a vapor phase pretty readily. And when in its raw form, if you just have TCE product and you dump it into a little dropper into water, it's denser than water. So it'll move through that water to the bottom of your cup. Same can happen in groundwater. So if raw TCE can penetrate all the way down into the soil, it too can move down below the water table and get deeper into the water bearing zone. From a health standpoint, particularly for human health, TCE is known to cause cancer. it also has non-carcinogenic health effects that affect livers, kidneys. There's a number of other factors that come into play. And when we assess the risk related to TCE, all of these potential impacts are taken into account. So it's not that it's cancer that drives, all of the numbers, cancer causing effects or whatever. It's whichever impact, is most significant at a particular level that helps us to assess the risk. So all of those things are taken into account, and I'm sure the health department could more eloquently describe that. But anyway, just to give you a sense, when we talk about what are our effective risk levels, which we're going to do on the next slide, I just want to make sure you understand that it looks at both the cancer causing and the non-cancer health related effects associated with TCE. So next slide. So, a couple of, when we go out and we grab groundwater samples and we send them to a laboratory and they analyze them, they give us a result. And what do those numbers mean? What do we compare them to? So what I want to try to give you a sense here is, what levels are considered safe, and at what levels, when we start to exceed those, do we have significant concerns? So for drinking water, TCE levels above 5 micrograms per liter, which is also equivalent to a part per billion or a ppb. Above 5 is considered unsafe, right? So when we go out and we do our sampling for groundwater, results above 5 are definitely on our radar. When we think about surface water or things like, the Cedar River, Saloon Creek, Shanty Creek, those types of things, the number that we're concerned about is 200 parts per billion. And that's related to values that would be unsafe for the aquatic ecosystem in general. So your macroinvertebrates, your bugs and critters that the fish like to eat, when might we be able to impact those? It's when you get above 200 parts per billion. And a lot of times, if you read our reports or you look at kind of the language used in terms of criteria, the surface water pathway is, how does groundwater move to surface water? It's what we call the GSI. So sometimes you'll hear us and read things about the GSI, and that really talks about how groundwater moves to surface water. That's what that acronym is supposed to mean and or refer us to. And I apologize because it's just the nature of the beast. There are a lot of acronyms in this line of work and in what we do. So another area of concern is, well, I told you that TCE is volatile. So if it's present in groundwater at the water table, it can be transferred from the water into the overlying soil, into the airspace in that overlying soil, become a vapor in that soil vapor space. So that's called the volatilization. When we can volatilize into that airspace, and then those contaminants in that airspace can move into things like structures that are built above them, so into buildings. So you get something that's referred to as a vapor intrusion. And the terminology that you'll hear a lot in the field is volatilization to indoor air pathway. And that's how we'll be referring to that tonight. You can look at concentrations in groundwater to get a start on understanding that pathway. And the screening level for that is 10 parts per billion when groundwater is not in contact with the structure, which applies across much of the impacted area. So kind of some big takeaways if I start talking about data and we talk about groundwater, just kind of remember 5 parts per billion, right, for drinking water, 200 parts per billion for GSI. And for screening levels for soil vapor, that 10 ppb number is important. So with that, we'll go to the next slide, because what is a part per billion, Len? You hear that number and what does it mean? And put it into context. It's a really small thing. So this is kind of some things that are that will help us kind of visualize it. You know, it's a penny in 10 million bucks. It's one drop of TCE from a little dropper in a swimming pool, or one heartbeat over 27 years of your adult life. The key thing, I think, if some of you may have seen the recent clip on 7 and 4 that talked about the Plume. And there we heard from folks that used to work at the plant, and they talked about using TCE sparingly. And I think the thing to remember is that it doesn't take much TCE to impact groundwater, right? So 5 little drops in a swimming pool, and you shouldn't be drinking that water anymore. So that's kind of that's the toxicity of TCE, and that helps drive that. So if we could go to the next slide. So now I want to shift into looking at the past site use. We'll just look a little bit about the history of the site, and then we'll look at some of the key environmental investigations that Eagle has been involved with, and that my company has helped support Eagle with over the years. You can see the site over on the left within Mansalona. And again, like we talked about in the middle, that's the photo that we saw earlier, which depicts the old Dura plant looking off to the northwest towards Shush Mountain. And then off on the right, we can see, that the plant is gone now, and the property is currently vacant. So we'll talk a little bit more about that history. Next slide. So Wickes Manufacturing was operated initially as an auto parts factory between 1947 and 1967 by Mount Clemens Metal Products. It was subsequently taken over, operated in a similar way by Gulf and Western. In 1985, Wickes Manufacturing bought Gulf and Western. They continued producing auto parts at the site. The key thing to understand is that, between 1985 to 1990, very short time period that Wickes owned the site, but that was also the time period at which the EPA in particular went in and assessed groundwater conditions at the site. So they installed some monitoring wells because there had been some Clean Water Act related laws passed prior to that, where folks had to acknowledge, companies had to acknowledge what types of hazardous wastes or hazardous materials they had used in their manufacturing process. So Wickes, who owned the property, had to say, well, once upon a time TCE was used here and disposed out back. That led EPA to install monitoring wells. That led to the discovery of TCE in groundwater at the site. And hence we now refer to this as the Wickes Manufacturing TCE site, or TCE Plume site. In 1990, Wickes was bought out by Dura Automotive. They owned and operated at the site through 2008. The plant was, after they closed in 2011, the plant was demolished. In 2003, though, while the site was owned by Dura, the site became state funded. Essentially, the state of Michigan recognized that we had a key employer in this town, Dura Automotive, that did not create this problem. And environmental investigations should not be something that weighed down their business. That was something that really just needed to be addressed. And so that's kind of what happened. So Dura closed in 2008, but just to be clear, since 2003, Dura was no longer involved in the environmental investigations going on at the site. The available records that are out there have shown that TCE was used up until about the mid-60s. So really in that Mount Clemens Metals era. So it doesn't appear that Wickes used TCE at the site. Dura didn't use TCE at the site. So again, neither of them was responsible for the release of the contamination, but they were on the property. Next slide. So we'll look real quick at a 1962 aerial photograph of the site. So this is at the time period when TCE was likely still being used at the site. You can see the site building off to the upper left a little bit of those pink arrows. Those pink arrows are pointing to the former untreated wastewater seepage lagoons, right? So wastewater from the site would be collected there and ultimately make its way down to the final effluent pond down to the south. Some interesting interviews that have been conducted, since this time have revealed, that those ponds would sometimes get kind of clogged up and wouldn't drain very well. And the solution was to drop some dynamite down, blast them open, and allow the ponds to drain. So what we have is a scenario where we had impacted groundwater or impacted wastewater that was sporadically released to groundwater over time at the site. And those create pulses that actually, we see a slug-like response in the groundwater analytical data that we collect from the site. So if we can look at the next slide, we'll see a little bit how the site changed. By 1981, those wastewater lagoons out back don't appear to be active. We can see a former unlined landfill off to the southeast. The lagoons that had been present on the previous slide, we can see have a little bit of water in them, but for the most part are dry. And if we look at the next slide, by 1992, right, we have done some cleanup in those to the south of the site where that landfill was, where some of those wastewater lagoons were. But unfortunately, the building up closer to the site has expanded, and where the former untreated wastewater seepage lagoons were, those have been built over. You can also see the green circles. Those are the locations where the EPA had installed the monitoring wells. They detected TCE in groundwater and essentially identified TCE as being related to this site and impacting groundwater not only at the site, but downgrading of the site. At the time of the TCE discovery, there was no municipal water in Mansalona, and everybody was drinking water from a well in their backyard or in their front yard. So those folks right across the street from the plant, they had TCE in their groundwater and in their drinking wells. So anyway, we'll move to the next slide. So key eagle-led investigation. So we'll talk a little bit about the environmental history. And one thing that I didn't put on, Janice and I didn't include on this slide, but we probably should, was that, the state's first priority in addressing and tackling this site was involved Mansalona proper and they recognized that they had water wells that were impacted. And so one of the main early efforts that the state invested in wasn't in terms of defining the groundwater plume and whatnot. Dura was doing some of that work. The state worked hard to work with the community and develop a municipal water system in Mansalona so that they could deliver safe drinking water to those impacted residences near the plant. So that was not really an investigation, but that was really some of the initial activities that the state engaged in at the site. But some of the things that have been done, since then, in 2006, there was a large soil investigation that was performed, while Dura was still active around the edges of the building, a little bit inside the building, but to the extent most of the work was done outside of the building to see if there were any residual TCE impacts in the soil below that building. That additional investigation along those similar lines was also performed in 2017. And in 2017, we also included the collection of actual soil vapor samples. And I'll show you some more about the soil vapor sampling in subsequent slides. Between 2004 and 2007, the state then engaged in vertical aquifer sampling to define the groundwater plume. This included collecting groundwater samples at 10 to 20 foot intervals from the water table to as deep as 600 feet below grade. So a lot of vertical, go to one location and you may collect anywhere from 10 to 15 samples to really understand where TCE was, not only at that location, but depth-wise. The state's done geophysical surveys. So we've looked at ways that we can kind of more cost effectively understand a broad area, perhaps identify the groundwater plume extent in some locations, but also more significantly and more effectively look at the geologic layering that's present, and look for potential other sources at the site. So, there's a couple of techniques that are in there that are listed here. We'll talk a little bit of, just to show you a couple examples in a minute here. And while it's not an ongoing, the ongoing program is to continue to monitor groundwater. So it's not like it's an active, discrete investigation, but we go out a couple times a year and we sample groundwater so that we can understand where the plume is, where it's going, how fast it's moving, and where it may be going next. Based on that, we then come up with a plan to install new monitoring wells so that we can stay ahead of the plume. So that's the Sentinel well network expansion. We've done some pumping studies using the Cedar River well field so that we can understand its potential vulnerability to the plume. We do surface water sampling in the Cedar River. So not only do we sample groundwater that's moving into the river, but we sample the river water itself so that we can see what types of concentrations we have there. We do stream gauging so that we can understand how much groundwater moves into these various surface water bodies, because that's a very important factor in understanding where the plume is going to go next. And in particular, we'll talk a little bit about some work we've done at Shanty Creek. And then another ongoing component that really has kicked off, I think, more intensively as beginning in 2017, are vapor assessments. So understanding what TCE may be in the soil and what structures above that soil may be at risk for TCE to move into them. So that's a very important health consideration. So next slide. So we'll just run through a few examples, show you some pictures, because a lot of the stuff that you see in these photos you may see us doing, or you may have seen us doing. We continue to work in the area. You probably will see rig setups like we show in the lower right with the 2 mud rotary rigs. We're hoping to get out and do some work like that this spring. We'll be in the area doing that, as well as some gamma logging. So you can see the gamma logging truck there on the left. We run a tool down the well. That helps us identify different soils that are present. So we can identify clay lenses where groundwater is not going to move very well, but it also can help us identify really nice clean sand zones where groundwater may preferentially move. And where groundwater may preferentially move is also where that contamination may preferentially go. So they kind of go lockstep. So those are some techniques that we use to investigate groundwater. But again, the current groundwater monitoring program at the site is basically a semi-annual or a twice per year program where we go out, we monitor groundwater elevations in 147 wells, and we monitor it at 4 different stream gauges in Shanty Creek and Cedar River, the water levels in the streams. We put that together to form an understanding of where groundwater is moving at the site, not only its direction, but its gradient, how fast, which impacts how fast it may move. And then twice per year, we go and we collect samples from our groundwater network, and we select between 42 to 50 wells per event, depending, in some areas we may be focusing a little more heavily along the Cedar River. Other areas, it may be more looking at that western lobe expansion. So twice per year we do that. And once per year, we go out and physically collect the samples from the Cedar River. So not only do we do that, but the state Eagle also engages with the Health Department in Northwest Michigan. They collect samples from residential wells. And some of you, I'm sure, have had Casey or Megan come out to collect samples from your home, from your tap, and to see and make sure that TCE is not impacting your well. Currently, the the health department sampling about 53 wells as part of their contribution to the monitoring program. Next slide. So again, we've done a couple of things, and this is just a snapshot. Some of you may have seen us back in 2006 and 2009 with this big truck, the Vibe truck, and we had all these little flags along the side of the road at 5-foot spacings. We stuck a geophone, and that truck would go and make this vibration, right? Connect, and we'd measure that energy as it would come back. And what we're really looking for was to understand the layering at the site. And you can see some of the results that we have on the right. The blue zones are a till. So one of the things that really jumped out from the seismic was the lateral extent of this glacial till, which is a poorly sorted sand, silt, and clay, just homogenized and crushed material that was ground below the glacier that turns out to be a very, it's not, groundwater doesn't move through that material very readily, right? And so the tills are very important. They help to prevent some of the groundwater impacts from moving vertically through the saturated zone. So getting seismic surveys were a really nice cost-effective way to identify these till units at the site. But you can also see, in particular in that lower right figure, there are some places where that till gets pretty thin, and it has almost, the top surface almost has, kind of, as we would call them, a smiley face look to it, right? That might remind you of the profile of a typical river. So that may be a channel deposit. So that type of feature could be a zone where I have, those old channels are really good for groundwater, even for groundwater migration, right? We think about them as old river flow conduits. And when they get buried and they get saturated by groundwater, they're a preferential pathway. Groundwater can flow pretty readily in those. So the purple lines that you see over there were when we took the seismic data, we said, you know what, this is a location we should probably investigate and install a well. So we could do a seismic line for about the cost of one well. So it was a really cost-effective way to get broad coverage at the site and enhance our monitoring well network. Next slide. Some other things that we've done at the site, as I mentioned, we did some studies at the Cedar River well field, and we used the monitoring well network around it to try to understand, not only as I move away from the well field, but also depending on what depth, right, my well is at. You can see we've got like 4 layers in this slide of contour maps that are brightly colored, yellow, blue. And those are the different zones where we have monitoring wells that we can measure when we turn the pumping wells on. How much does the groundwater elevation change? How much drawdown do we see? So that's a way for us to understand the connections, the potential connections in that groundwater system that result from pumping. And when we do that, one of the things that's real interesting, you can see the magenta zone in the upper right, that's that groundwater, that's TCE and groundwater. That's where we know we have TCE and groundwater at the time that this study was done. And you can see at the uppermost layer, right, the red number, less than 0.1 feet. So that's really, we can't really resolve a response when you pump at the Cedar River well field in that zone where the TCE is moving. Okay, so that's good, right? Because that means that the TCE impacts are going to flow with natural gradients and do not appear to be affected by the Cedar River well field. As we move deeper into the aquifer, that next layer down, we can see some response isolated, right, localized. Those might be zones where we have some thin spots in the till. And so we might have a little bit of a hydraulic connection, and we did see some drawdown, generally of a foot or less. But as you can tell, when you get below that till zone, right, the groundwater elevations, there's a lot of water that's being drawn from the aquifer in that zone towards the Cedar River well field. So one of the things that we learned from this study was that, you know, hey, if we don't pump on the Cedar River well field as hard, right, then the drawdown that you see in that intermediate zone, that 1 foot or so, should also go down. So this study helped us to work with Mausa to really reassess pumping rates and how we operate at the site, and ultimately led to the installation of a high pressure water line from Mansalona directly to the Cedar River well field, as well as the installation of a storage tank at the Cedar River well field, also that we could reduce the day-to-day pumping at those wells, right? And reduce that risk that someday they might get impacted. Next slide. Some other things that we've done, we've gone out to Shanty Creek, we do some stream gauging, we do it, you know, throughout different seasons, so that, because obviously things are going to change a little bit if you're worried about how much water is moving in this stream in the spring versus how much is moving in the winter, right? There's a seasonal component. And what we learned when we did the stream gauging is that there is a lot of water moving into Shanty Creek, in particular from the pond that you can see, kind of in the center of the map. That's on the golf course. And then just below that pond, and it flows out. Yeah, there we go. Thank you. Right. And you can see a stream gauge number 3. In that section of Shanty Creek, there's approximately 3,200 gallons of groundwater flowing into the creek per minute. Right. So that's a significant volume of groundwater that's being discharged to the creek in that particular section. The amount of groundwater that moves into the creek, you know, to the west of that gauging point, station number 3, SG3, is significantly lower, right? So that is telling us that there's perhaps a preferential pathway for groundwater to move towards Shanty Creek. And if you look at the map, you can see the green dashed line for the plume, and we see that plume bending also and kind of following that same trajectory. And when you look at the blue zone that we see there, right, that's where we also have gathered some data from monitoring wells that shows that groundwater can move through the aquifer, through the formation at a slightly faster rate. It has a higher hydraulic conductivity, would be the word we would use. So we kind of found this high hydraulic conductivity zone that moves towards Shanty Creek. A lot of this is pointing towards, this is where the plume is likely headed. Next slide. So with that, let's kind of put it all together into a conceptual. I know I threw a lot at you, but just wanted to give you a sense of some of the things that we do at the site. And you likely will see wood folks and eco folks out there doing some of those things in the future. We'll kind of roll into our conceptual site model, put the data together so that we can understand risks and potential exposure pathways. Next slide. So in terms of a conceptual site model, the idea is to keep it simple, right? And kind of lay out where impacts are and how they may move or affect people, right? So we can see, you know, over on the right, we've got the plant. And below the plant, we have TCE impacts in the soil. There's some low-level residual concentrations that are there. They're not so high that we need to be worried about construction workers coming into contact with them and that posing a direct risk. But they're certainly high enough that they can contribute, they can continue to help feed contamination to the groundwater zone. So there's still leaching that can occur to the water table from that source at the site in the soil. Likewise, that residual source in the soil, we have that volatilization effect. So some TCE can be absorbed onto soil grains, but some of it will exist as TCE is a vapor in the soil pore space. Ultimately, that gets down into the groundwater, and we can see as we move from right to left, right, that plume moves, that plume impacted area drops down a little bit, right, follows natural gradients as it moves from right to left. And there is some white clean zone up above in some areas. So where the water table is impacted, where TCE impacts are present at the water table, you can see the little black squiggly line under unsaturated sand. Those are zones where we might be concerned about volatilization of TCE from groundwater into the soil vapor space. So likewise, what this also shows us is that, we need to be worried about drinking water wells. Are drinking water wells potentially installed in the groundwater plume? That's a definite risk at the site, right? And that's one of the driving factors that causes us to continue to do work at the site. And then, of course, as we move to the left, the other thing we need to worry about is, what about surface water? We know this plume moves towards the Cedar River. Is that causing a problem for the Cedar River? So, just try to create a simple snapshot that helps us to understand kind of those three main pathways that we have at the site: vapors, right? And then we have drinking water. And in particular, we have, and then we have the ecological risk at surface water. Next slide. So with that in mind, let's back up a little bit and put the data together and understand what we have. Where is TCE? I've shown you the green map, right? That shows where the footprint of TCE is. But what does it mean vertically, right? Where is TCE if I go to a particular location, where would I find the TCE? Generally, as we move away from the site, we see TCE kind of divided into three zones, right? There's a shallow zone where TCE impacts tend to occur at about 50 to 100 feet below the top of the water table, right? So if we drill down, and it varies from place to place, some locations we can drill 10 feet and hit water, like for example, near Shush Mountain, the base of Shush Mountain. But when we move up towards Troon Road or Del Mason Road, and in that area, sometimes I've got to drill 250 feet before I even hit water, right? And then I need to go another 50 to 100 feet into that water bearing zone before I really find TCE. So where TCE, where I might find TCE depends not only on where I am spatially, location wise, but also vertically, how deep I am. And the shallow zone is definitely the area, as you can see on that cross section to the right, that simplification, where we have the greatest extent of TCE, right? The TCE has extended the furthest in the shallow zone because it's migrating at a pretty fast rate, 330 to around 500 feet per year is how fast TCE moves in this aquifer. And that is a fast clip. It's also a zone that's pretty common for residential wells to be installed at, right? I mean, it costs more money per foot to install a well, so the deeper you go, the more expensive it gets. A lot of the wells tend to be in that 50 to 80 feet below the water table zone. Number one, just to make sure you got enough water to produce, but also that's where, it's a good system. It produces a lot of water. So that shallow zone is one that's of particular concern for residential wells, and it's the area where the plume is moving the furthest. When you look at our maps that we generally present, we tend to focus on that area in particular because that's the area of highest risk and greatest extent. There is an intermediate zone. We get down towards the top of that clay, that till layer that we were talking about. There's significant contamination down there. It moves a little bit slower, around 100 feet per year. And that's a zone that we want to watch because that's the zone that vertically we don't want it to move into the deep zone at high concentrations. And for the most part, that's what we see at the site is we see very little TCE that has been able to migrate through that clay or till into the deep zone. And contaminants in the deep zone migrate at a slower rate, less than 50 feet per year. And this zone is also the zone where the Cedar River well field withdraws its water. So this is a zone that we also monitor closely, particularly as we move to the west towards the Cedar River well field. Next slide. So with that kind of conceptual understanding of the plume, hopefully I didn't pass over it too quick, but maybe this figure will also help us. I want to talk about the volatilization to indoor air pathway. So the vapor component pathway, and kind of, really hone in there. And as this slide shows, right, the orange, or sorry, I'm not great with color, the reddish pink zone above the blue water table, that's the location where vapors may move, TCE vapors may be present. And so you'll notice when you look at the shallow TCE plume shown in green, right, where that plume touches the top of the water table, that's an area to be concerned about for vapors. When I look back at the source below the building, right, and I have some impacts in soil, that's another place where I need to be worried, especially about vapors. But those aren't the only places, right? As I look down gradient, I see that the plume, at some points it's kind of deep, but it does come back up to the water table at places like the Cedar River, where groundwater is moving from the aquifer system, into and feeding and sustaining our rivers. So that's another area where I need to be a little bit concerned about whether or not volatilization into the vapor space is occurring. Next slide. So we're going to look a little bit at what we found at the source area. And so you can see kind of the magenta bean over on the right-hand side of the slide. This is the footprint, if you will, of the extent of the TCE that's actually been detected in soil vapor. So down at the bottom of the slide, you can see us, we're working with the driller to install at a specific depth using a center pipe, a short well screen that we can then use the equipment on the right to assess for the actual vapors. So we can draw some vapors into a bottle, send that to the lab, and they'll analyze it. And we'll be able to know just what levels of TCE are in our soil vapor, right? So it's a much more effective way. Groundwater can tell us something about the screening level, but this is a much more direct way to understand what's actually in the soil vapors. Some of the things that we've learned, right, is that seasonally, soil vapor concentrations change, right? And in summer, in particular, late summer, we tend to get, the ground is warmer, the groundwater table is a little bit warmer. All of these things help to promote volatilization or movement of TCE from the groundwater system into the soil vapor space. That's when we tend to find the highest concentrations of TCE in soil. We also find that TCE concentrations in the soil vapor are higher, closer to the water table. So confirming that notion and that understanding that TCE present at the water table is a pathway that contributes TCE into soil vapor. So, if we know where TCE occurs in the water table, we should have a pretty good sense of where there's a vapor risk, okay? But the results, you can see that the contamination extent in the soil vapor has approached 3 buildings to the west of the site across the street. Ultimately, we went inside of those buildings and we took samples right from below those buildings. We also collected indoor air samples inside of those buildings as well as other buildings in the area, so that we could understand, it's one thing if you have TCE and soil vapor, but that doesn't necessarily mean that you have it in your indoor air, so you want to confirm those. And so we did have some detections of TCE in some indoor air. And as a result, right, you can see the buildings that are shaded blue, purple across 131 there. Those buildings have been treated. We went in and, you know, the Michigan basement, that was all joints between the rocks that needed to be sealed and make sure that, you know, vapors couldn't move through those. So we did a lot of sealing work. And then once that was done, we installed subslab depressurization systems, which is a mouthful, SSDS. But basically it involves, you put a little bit, you put a little hole in the floor, stick a screen down in it, and then basically apply a vacuum, right? So we just suck the air from below the floor out of the building and vent it to the atmosphere. And what that does is it creates a pressure difference between the building and the floor. So the building will now have a higher pressure than the floor. So if air is going to move from one system to another, from the building to between the building and the floor, it's going to move from high pressure to low pressure, right? So any air movement will be from the building down rather than from the outside in, right? So they're a very effective way to control vapors. And those systems have been put in place at 3 buildings, and we continue to monitor soil vapor and indoor air at other buildings around these areas. Next slide. And this just gives you kind of a cross section. This is a very data-based, you know, summary of what we've been finding and where we look. You can see that we have a number of little black squares that are pretty deep. Those are important for understanding how soil vapor is related to groundwater concentrations, you know, so how those two things can go hand in hand. And then ultimately, you know, looking at, in particular, we tend to put a lot of focus on potential receptors. So where would these vapors potentially move? And we want to get, you know, next to those buildings, get close to those buildings, and get deep down below those buildings so that we can understand what's going to happen. Because a building can influence what happens in the ground below, right? And winter is a great time to think about it. We all got our furnaces turned up, right? And warm air rises, you know, or you leave the door open and that cold air comes in, warm air goes out, right? So that exchange is occurring in the winter time, especially. And that can be a time when, you know, some of that air that you lose from warm air through that goes up through the chimney or up through the roof, right, gets made up by air that can move from below. So this is a critical time for us to be operating those subslab depressurization systems in some of these buildings. And you can see that, you know, at the commercial property in the center, we have that subslab depressurization system in place. That building has drawn some of the vapors upward, but they can no longer migrate into the building. Next slide. Down gradient, and I know this is a little bit busy, but I just wanted to give you a sense of what we do down gradient. So again, from the conceptual site model, remember the areas that we need to be concerned about are areas where TCE in groundwater moves back up towards the water table because that TCE may be venting to wetlands or to the Cedar River. So that kind of pink area in the center is the area where groundwater is located pretty close to the surface, you know, within anywhere from 5 to 35 feet below grade, depending on where you are. So that zone's a zone where, number one, the water table is kind of close to the surface. And number two, we have some locations within that zone where where TCE is moving up towards the water table as that groundwater vents to the Cedar River or other areas. So the samples that are shown with the pink top, those are soil vapor samples. And the samples that are shown with the blue label, those are groundwater samples that are collected right from the top of the water table. And so you can generally see, you know, in particular, where those red circles are, those are zones where we see TCE in the water table, or at the water table at concentrations that are above that level of 10. That's our VIAP screening level. And so those are areas of potential concern. And however, we have not measured TCE and soil vapor concentrations that exceed screening levels for indoor air. So it doesn't appear that that pathway is currently complete. However, we are going to be doing some more investigation work in 2022 this summer to look at in more detail at both conditions in the water table and in soil vapor. And those are those red zones that are shown on this slide. Next slide.
Hey, Len, just a quick time check for you. We're sitting right at about 6:56. We want to make sure that we provide a little bit of time here to answer some questions at the end. So just wanted to give a quick update for you.
Thank you, Mike. I will try to speed up. I get in these and it feels like we got more to talk. So in terms of ongoing assessments of the VIAP or the vapor intrusion pathway, just as I mentioned, we are going to be, we continue to monitor at the site seasonally, and we do look, we will be doing enhanced sampling, with some new locations again in 2022, just to get to make sure that our current conceptual site model is correct. Eagle has installed the SSDSs at the 3 offsite properties and continues to support the property owners in operating and maintaining those. And basically what we've learned for sure is that, future development of the site property is definitely going to need some vapor barriers or subslab depressurization systems, right? The concentrations in soil vapor at the old manufacturing plant are pretty high. And so any future development is going to have to take that into consideration. And there's definitely ways you can engineer and build over that and mitigate that risk. But it's something that needs to be on everybody's radar. Next slide. So now we'll get into the heart of the groundwater plume impacts and management. And I think, Mike, I'm only got about 10 minutes left. So, so again, the shallow groundwater plume, that green zone that you see on the map to the right, that's a pretty big plume. It's one of the biggest in the country. It's about 1.5 miles wide and extends over 6.5 miles from the release location. We know that a portion of it vents to the Cedar River, as we've discussed. And that TCE plume has already affected over 500 residential drinking water wells and some former shallow community drinking water supply wells near Shush Mountain. And the path forward, the way that this plume is being addressed, and how we mitigate exposure is as that plume moves into areas where there are residential wells, those wells are sampled, and ultimately the water line, the municipal water system has been expanded over the plume to ensure that everybody has safe drinking water that is provided from the wells up gradient of the site or to the east of Mansalona. And you can see those as the black filled dots back in the Mansalona area. So that the way that the state is managing the risk associated with drinking water, again, is making sure that you don't drink the water, right? And you don't drink unsafe water. So we extend that municipal water. There's also institutional controls in place, which is the well first policy, and I'll talk a little bit about that. Next slide. So again, first things first. Ooh, that kind of turned out a little. Just to remember, we do have a lobe of the plume that is venting to the Cedar River. We monitor that once per year. We have samples that we collect from the base of the river, from the river's edge, and from the river itself. So we sample groundwater from below the river as well as in the river. And then we've sampled to the north of the river as well to make sure that impacted groundwater doesn't move under the river and potentially keep going. And basically what we found is that the groundwater impacts vent to the Cedar River. It doesn't move beyond this to the north side of the river. And TCE has not to date been detected in groundwater near the Cedar River above that 200 part per billion level. That would be detrimental to the aquatic ecosystem. So we continue to monitor it. It's not ideal, but the good news is, you know, that even biological surveys that have been done in the river confirm that the TCE venting there does not appear to have a detrimental effect on the aquatic ecosystem. So that's good news. And we also see, you know, as you move downstream from this groundwater venting area, the TCE is not present in the river. So it moves into the river and then it readily gets exchanged and volatilizes out and ultimately destroyed in the atmosphere. Next slide. All right, but where is this shallow groundwater plume going? This is the thing that keeps me up at night. So the West Plume expansion. So when we look over along Shanty Creek Road, Del Mason Road area, what this figure is showing you is the changes in the plume extent over time. So basically, you know, you can see a snapshot of the plume in 2008, where it was just crossing Dalmatian Road. We had first detections there. And then over time, it's now since progressed to the west through Zwischendorf Trail, or, you know, by the Church on the Hill area. And it's now moved over into Shanty Creek. We had detections in Summit Village in 2018. And the water line has since been expanded into that portion where we had those detections along Windy Hill Road. And you can see the current extent of the plume. I don't know, Mike, if you can kind of trace over that line. Yeah, there you go. And look at this little bulge up as you keep going to the upper right, right? So interestingly, we've had a recent detection at a residential or a commercial well just to the north. So this is kind of a new development in 2021, which kind of demonstrates a little widening of the plume in that area. And when you contrast the plume width to the west with the plume width to the right, you can see those red lines have been added, those double-headed arrows, to give you a sense of how the plume will change over time. So not only does this plume move laterally to the west at about 320 to 500 feet per year, but it also is going to get wider as it moves in that direction. Ultimately, it's venting towards Shanty Creek. But the progression is pretty clear in terms of where it's going. And we can't forget that it's also going to get wider as it moves in that direction. Next slide. This is just a cross section, again, to kind of show you vertically how those things have happened. Again, we've had some new detections, but generally speaking, those groundwater concentrations, those detections in groundwater are occurring at about 50 to 100 feet below the water table, which is shown by the blue triangles. So you just kind of wanted to vertically put that into perspective. So not only does the plume change, does it grow laterally over time? Does it spread out, right? It gets wider as it will move through this area, but it'll also vertically affect more areas, right? So for example, the well at 6373 Shanty Creek was a little bit shallower than the monitoring wells that have detected TCE in the area for 3 or 4 years. Well, over time, now we have that groundwater creeping up a little bit and expanding, and was detected this year in that residential well. Next slide. So thinking about preventing drinking water exposure, current and next steps, right? So the ultimate goal is to provide a safe source of drinking water for residents in the area. And I think that also is significant because it adds peace of mind, right? So when we can get on a municipal water system, we know our water's safe. And that I think is paramount. But we also have another policy that's out there, and that's shown, that's that pink area that's shown on the map. That's that well first policy, which is a look before you leap kind of policy. So the health department helps to, if you want to build a house in that pink area, there will be a permitting process that the health department will help you to work through to make sure that your well, if you're going to install one, is not likely to be impacted by the TCE plume. So if we can go to the next slide. And really, if you have questions about the well first policy, I highly encourage you to reach out to the health department in Northwest Michigan. The folks over there are super helpful, easy to work with. We work closely with them also to help guide them from a scientific basis to understand where the plume is and what might be best. But you know, the policy is intended to prevent the installation of new wells where public water is available or based on the proximity to the known extent of the groundwater plume. So if you're close to the plume, you're also going to need to work within the constraints of this policy. And the goal is to identify what depths you might want to avoid installing your well to avoid contact with it. There's some water quality requirements. There's some well construction requirements to make sure that your well isn't installed and allow leakage for the impacts to potentially get in. So a number of things that it does require. And I think that's probably enough on this slide. I think definitely contact the health department in Northwest Michigan if you have more questions about the well first policy, but it is in place. Go ahead, next slide. So the next plan though, you know, we talked about the plume expanding to the west and the fact that it's going to widen over time. And so the plan that's in place, right, is to expand the current extent of Mausa, which you can see extends to Windy Hill. Mike, if you could. So just to the left where that, not the, yeah, that arrow. So right now we've got the current Mausa water line extends to that location, again, driven by a detection of TCE along that road, along that area. And that's where our plume is currently. We see evidence that it's widening. You know, not only when we look at the new detection from 6173 Shanty Creek, but when we look even further back, right? So it's towards Del Mason Road, and we see that much wider plume. And the plan that's in place is to take advantage of some new funding mechanisms that allow us to be proactive and get the water line extended before everybody starts getting impacted. One of the reasons that might be important is every one of these wells that you see are drawing groundwater and influencing potentially where that plume moves, right? So the sooner that we can allow that plume to move towards Shanty Creek, resume its natural flow, the better. So there's good reason to extend the water line and stop the pumping that's occurring in the area. We've identified some priority areas, you know, and those are kind of highlighted in the pink zones here. And the engineering's been initiated. So if we go to the next slide, we can kind of see how this pans out. So you can see the current Mausa service area, which goes a little bit down Deskin Drive and hits Windy Hill on the right. And then we have a phase 1 and a phase 2, P1 and P2. Those are the two zones that you know, are where the plume is most likely to impact in the near future. Those areas are prioritized for the water line development that you're going to hear a little bit more about in the next one. The phase 3 and phase 4 locations, you know, those are additional locations where water line expansion may be needed in the future. And we will be putting in some additional monitoring wells to help us constrain and better understand the plume movement as it continues to progress to the west towards Shanty Creek. Some of the things to note, you know, as part of this water line expansion, the engineering is including, you know, service drops to existing homes. And that, you know, as part of that, Eagle will abandon your existing residential well for you at no cost. At some of those locations, we may talk to you and see if you'd be willing to allow us to use those as monitoring wells, because that'd be a very cost-effective way to get a little better understanding of the groundwater flow patterns that occur at this as we move, the plume moves to the west. Next slide. So as I mentioned, we'll also be installing some additional monitoring wells. Those are shown in green. Those will help us to better understand and make sure that we delineate the plume, not only currently, but over time. So remember, we anticipate this plume to widen as it moves to the west over time. And those will help us with that. And hopefully some of these wells will remain clean wells, and we won't see the groundwater impacts migrating through them. But we also need those wells to make sure that we understand the groundwater flow direction. So some of those wells are targeted for that, to improve our understanding of groundwater flow. And I think we can go to the next slide. So I guess, the thing I want to leave you with is stay informed, right? We will definitely be working with Janice and Eagle to do future public meetings. We have the Eagle fact sheets and reports, which I think the fact sheets in particular, which Mike has uploaded, but reports that are generated for the site, they're available through the health department. There's also copies that are maintained at Antrim County, at the Antrim County building, Mansalona Township building, and the public libraries in the area. So, and you can always reach out to Janice Adams as well. So we also have this online mapping location application. The path to access it is down below, and it's a handy way to see where your property is and what impacts have been measured in wells in the area. You can access the individual data from all of these wells. So with that, I apologize for running long. I know I can talk too long, so we will turn it over to you, Mike.
Yeah, no, I appreciate that. All great information. And it looks like it spurred some conversation in the question and answer box. I'm going to take zero time and ask, I believe it's Aaron is going to share your screen. And it's got a few slides that you want to share with us. So Aaron, if you're ready, and Jim, feel free to jump in and start sharing your screen. We can dive right into it. Thanks.
Thank you. I'm Jim McCory. I'm the field manager with Mansalona Area Water and Sewer Authority. Just want to give a little brief history on how MASA formed. Obviously, in 2000, I guess the next slide there, Aaron, please. There you go. In 2000, the Mansalona Area Water and Sewer Authority was created by the Mansalona Village, Mansalona Township, and Custer Township. It was at the suggestion recommendation from, at that time, it was the MDEQ, which is now EGLE, to put the existing systems together, and they would help fund everything, getting everything put together in between. So there's two plumes actually. There's the Wickes plume and the Tar Lake plume. So we cover water mains on both of those. The EGLE funds all of the water main extensions as the plume has been advancing, and has over $20 million in that. And Janice can probably give us a better idea on that. In 2011, the MASA board recognized that the existing water mains that were undersized and very old, causing a bottleneck of trying to transport the water from the clean source of the wells on the east side of Mansalona Village to the west, where all the water main extensions have been made. The MASA replaced all these undersized mains that were half of the mains in the village. A new well was also drilled, and the existing three were repaired and updated at that time. The cost of this project was $3 million, and it's still being paid for by the existing users. The MASA now has over 70 miles of water main serving over 1,600 connections. We have over 1,000 fire hydrants, thousands of valves, 7 pressure reducing stations, 2 booster stations, and 6 wells. Some other MASA facts that might help is the MASA is a nonprofit municipality, and the only income is the user fees levied monthly. We read our meters every month, and we bill monthly as well. The bills are usually sent out around the 15th of every month. The MASA board meets the first Tuesday of every month at 6 p.m. at the Mansalona Township offices at 9610 South M88 Highway in Mansalona. Our office hours are 8 a.m. until 12 noon and closed for lunch, open from 12:30 till 4:30. I guess with that, I'll turn it over to you, Aaron, and continue on.
Okay, thanks, Jim. So Len kind of touched on this, our phase 1 service area and our phase 2 service area that are the subject of the current projects. And in order to supply water there, what we've got is the existing supply and tank capacity at the Cedar River well field. Then we have a 12-inch transmission main line that comes in and up Deskin, where the Windy Hill area has a smaller 6-inch line just serving the homes in there. The extension has already planned for these future projects with this 12-inch transmission main, and the existing source and tank capacity here is adequate to supply the demand for the current projects that are proposed. So you can kind of see here the proposed phase 1 and phase 2 service area have a mix of existing homes, which are represented by the red dots, and the triangles, the black triangles represent vacant lots. So the project would supply water to both the homes, getting them connected on, and then service taps would be left to each vacant lot, running it up to the property line. So just to give everybody kind of an idea of what happens when we come in for a water main extension project, the basic gist of it is that we're going to have about a 7-foot deep trench that is running along the side of the road. You can see this is the 12-inch, that's a plastic water main pipe under construction. At any given time, we probably have about 60 feet of trench that's active, where it's, you know, being backfilled behind here. They're working on installation, and then they're digging for the next section of pipe. This works in a linear progression along the road. And in this scenario, the normal flow of traffic is usually maintained. There's usually just minimal localized lane shifts and temporary disruptions when this trench has to cross like a driveway or something like that. So when we get to an intersection between a transmission line and then a service going into, say, a road on a cul-de-sac or something like that, we put in a fitting and run a reduced size pipe up into these what we call branch piping, and those branches serve homes on those stretches. And then we have isolation control and fittings that go into all that. When this happens, we cross an intersection. There are more disruptions to traffic. There's a little more coordination that has to happen for those disruptions. They're usually, done within a 2 to 4 hour time frame. Traffic can come back across where we backfill it. When we finish up, the only thing you really see at the surface of the project is individual curb stops, which are these little boxes here, which are connected to a valve down underground that shuts off and isolates the service lines to individual homes. Those are what are called a curb stop. And of course, you'll see fire hydrants and other isolation valves on the larger piping. Other than that, all of our work gets buried. So a big question people usually have is, what is this really going to look like when it's going on in front of my yard? So it's going to be bad for a little while, right? So you got a 7-foot deep trench that takes up, a good width across the surface to be able to dig the holes, stockpile dirt, and keep the operation going. However, the contract with Eagle and Massa requires a contractor to restore all this back to the existing conditions as well as they reasonably can. When we're coming through, it'll look rough. And like in this scenario here, you'll cut this driveway. We'll do some coordination with people to make sure they know when we're gonna temporarily disrupt access to your driveway. If you have appointments or things that you need to get in and out, we talk to people, either have a car staged on the other side of the trench, or we work with you to make sure this is accommodated. But at the end of the day, what we're trying to do is get you put back like this. There'll be some portions of the project that require us to cut the actual roadway that you can kind of envision. You know, there was a hole here with piping exposed. So somebody coming from this direction can't get through for some period of time. Somebody from here can't get through. So what we like to do is have coordination, usually like a single point of contact with the association works out the best. That this person can then disseminate information back to the homeowners. And what we try to do is minimize these impacts, make sure they're coordinated, and then at the end of the project, get them put back so they look, you know, as good as we can make them. There's some sections of the project where we have steep banks. You can see the hill here coming down into the road. And there are portions of phases 1 and 2 where we have this exact scenario. We have narrow roads, we have some steep terrain, a lot of trees we don't want to cut. So parts of this project, we will run the pipe right in the road. Now, obviously, on the plus side, you get a new road at the end of this. But on the negative side, this is more of a disruption for a longer period of time that creates more coordination that we have to do. And this is where, you know, good communication with the association, us and the contractor is key to making sure the homeowners maintain access for everything they need during the project. Once we get out of the roads and we've put things back on what we call the mains, the contractor will get those tested and turned over for connection into the overall water system once they're deemed safe. And at that point, they usually jump back and they start doing the individual connections to houses. And this is probably what a lot of people are interested in if you're a homeowner along there. So basically, every homeowner, you're gonna get provided with a new water service connected to the main. We're gonna come in, we're gonna abandon your well. We're gonna replumb inside your house to get rid of your bladder tanks, pressure switches, controls. We'll give you a new meter and pay tap fees to MASA. And that way you're essentially made whole through this process so that you don't out of pocket have to make any investment to get this connection done. It's all being covered through this Eagle and MASA contract. Now, when we come to abandon your well, what they do is they remove the pumping equipment. This is a well casing going down into the ground. So this gets filled in with grout. Then they come down here, this is 3-4 feet deep. They cut it off. And at the end of all that, it looks like this. And just a little spot in your grass where we have to do some restoration, get it going back in. But you can kind of see over here, there's the top of the well casing, the pump, drop pipes and that stuff. It gets removed. We don't leave it in your yard. That's just temporarily there. That all gets hauled off site as part of the restoration. So obviously the timing of this will work out better for some than others. You know, if you just put a new well in or a new pump, it might look like this. You know, this one, a couple, 3 years old, you might get another 10, 13 years out of this thing. But if this was your well pump, you were a big winner in this project, because this pump, to replace it, costs you about, on average, something around $3,500. So, you know, even though we come through and we hook you up to the municipal water, you have a benefit by getting rid of some of this homeowner obligation in terms of the ongoing pump replacement cost. If you figure this pump's gonna last you 10 to 15 years and you amortize this out over, say, the 15 years, this really is equivalent to about $20 a month you have to save to be able to just write a check for this when it's ready to be replaced. So that's a good benefit of this project. Some of the other benefits of connecting to the MOSSA system, there are financial impacts to homeowners once you're connected. The big one is obviously you're going to have a monthly water bill. Now, this is the current 22 rate schedule for MOSSA. You can see the ready to serve. This is kind of the base, the $31.55. That's the base cost that MOSSA bills to be, we call ready to serve. It's ready to provide water to you, whether you use it or not. And then you pay $3.10 per 1,000 gallons that you consume. So if you do the math on that, a typical bill for residents ranges from about $40 to $50 a month if it's occupied. And in the summer, those of you who have irrigation systems, this is where it can be expensive. In summer months, if you have a typical size lawn, it'd be around $100 a month for watering, depending on what you got going on. So the benefit of what you get for paying these water bills is, number one, like we discussed, when the pump fails, you have, it's not, you no longer have that liability of a pump failure. That $20 a month is essentially cost shifted off of your responsibility. The other thing that happens is we bring fire hydrants, and this firefighting capability usually results in insurance rate reductions. If you look at the value of the homes in this Summit Village area, obviously there's a lot of factors that go into insurance rates and all that, but typically on an annual bill, you'd save a couple, $300 by having access to the firefighting. And so something about another $20 a month or so reduction in your insurance bills should be realized through the project. The vacant lots, no longer subject to well first policy. And honestly, the vacant lots, you're really the big winners in this, because the vacant lots, you'll no longer have the cost of installing and drilling your own well out there. You have a tap provided right at your property line, ready to go for you. And you won't even get a water bill. So the other thing that happens is when you do install a well out here where there's no sewer system, you have these 50-foot isolation areas around the well where you can't have any septic tanks, drain fields, that type of stuff. These well isolations do create conflicts. Your neighbor puts his well 10 feet off the property line, and now 40 feet of your property just got eaten by his isolation area. So the properties in this area are generally large enough that this isn't a huge issue, I would imagine, but it is one less thing to worry about when you're siting infrastructure on your own property. Of course, the big one, you don't have to worry about your well getting impacted by TCE. The bottom line of all this that we'd like to drive home here is that, yes, you'll get a water bill every month once you're connected. And it's true that this water bill comes to you every month. And if you look at the overall picture, we feel that this is essentially offset by your no longer having a responsibility for operating your pump replacement, bladder tanks, that stuff. And then if you also think about the reduction in insurance rates and that kind of thing, it really is close to a net zero cost if you're in this average $40, $50 a month type range. If people independently today were to go to connect to MOSSA, it would cost about $7,500 between tap fees, well abandonment, new service line, and plumbing modifications. This work's being offered to the people in the service area at no cost. All of this is getting invested to your property at no cost to you. Not to mention the less tangible benefit you get by having this infrastructure installed out through your community. You have these fire hydrants, you have access to municipal water. What we really see is the value of homes in this area should be increased by having municipal water. It's not only preferred by a lot of people who move up north from more urban areas, but it eliminates this concern of having property that's located in or very near this TCE plume. And I've heard, a lot of people, you get used to drinking the water you have from your well, but I'd like to assure you that the quality of the water that Jim and his team are producing is really awesome. You can see here, they got 11 years, they've been the best tasting water for our region. So once you get connected to the MASA system, you will have a very high quality product. And this water gets tested periodically for contaminants and water quality parameters. And the guys out there are always doing their job, flushing, maintaining, taking care of this thing to make sure it's here for the long haul. So that's really the gist of what I wanted to cover in terms of the impact to people when this project comes to you, both on the construction side and on the financial side. Other than that, Jim, if you have anything you want to add, I'll just conclude it there.
The only thing I'd like to add is I do have all the awards here from our water quality, best tasting water. So if you want to.
There you go. I didn't just make it up.
Nope, they're right there. And we did win in 2010 for the whole state. So we have 10 regional awards, and then we have the rest of them right here. So thank you very much.
Yep, thank you.
Great. Well, thank you, Aaron and Jim. I'm going to quick share my screen again just to remind folks how they can ask questions if they have any questions. Remember to use the Q&A box. We do have a handful that I'm going to try and run through and see how many we can get through here before the end of the meeting. But then also feel free to raise your hand. And if you're on the phone, I didn't see that we had any folks on the phone, but if you are on the phone, pound or the hash sign and then the number 2 will raise your hand. So one to kick it off, we had a handful of questions. Folks were interested in getting their water tested. So if someone in the area wanted to get their well, their tap water tested, who would they contact and how would that be paid for? Is that something that Eagle would cover? Is that something that they would have to cover themselves? And who would they reach out to?
I can answer that question. Right now, Eagle is sampling approximately over 100 residences, private drinking water wells in areas that are just outside of the municipal system. And some of those wells we sample yearly and some of them we sample on a quarterly basis. If you can get a hold of the health department, I think Casey and Dan are both on the line right here, and we can work with you on where your location is at. And if it's a well, your home is in the area that's close to the area where the TCE is Plume, we have been sampling those wells. If your well is not in an area where we think it's going to be impacted, then that responsibility of sampling your well will be on yourself. And once again, the health department will be able to at least lead you to analytical companies that can help you in getting your well sampled.
Great, thank you. A question about the wells that are used by MASA. Have any of those wells, have they detected TCE in that water? Not necessarily any exceedance of the 5 part per billion number, but even any detections of TCE in those supply wells?
I can best answer that, Mike. We test the Cedar River wells get tested monthly. We have never had any detections there at all. The other wells that we have are all on the east side of the Plume, over a mile, about a mile and a half away from the Plume, which is flowing the opposite direction. So the only ones we really worry about are Cedar River. And like I say, we test them every month, and we have not had any detections at all. So,
and I want to repeat what you said, because I think that was another question. You said the Plume is about a mile and a half from that well field. Is that what you said?
No, a mile and a half from on the east side, where the origin of the well. We're
Gotcha.
actually
Okay.
a mile and a half to the east of the origin of the well of the Plume.
Okay. All right. Thank you.
Sure.
There's a question here about, in Summit Village, is there a real possibility that some of those lots would never need to hook up to the water line? And so I know that's a tough question to answer, because it's predicting the future. But thinking about, maybe the Plume and where it is and where we, currently have it mapped out, is there a real possibility that some of those in the village never need to have their lots hooked up to the water line? And I don't know if that's Janice or Len or who may want to try and take a swipe at that.
You want me to, I can jump in on that one, Janice. I think.
Thanks, Lon.
There's two things that we see, you know, that obviously we have the plume direct trajectory that's moving towards that stretch of Shanny Creek between the pond and where we have the gauging point. We know that a lot of groundwater vents there, and that seems to be a preferential flow path. But the concern, the difficulty in predicting it is the amount of, you know, that's the way it's moving in the direction it's moving. But remember, it also laterally spreads out over time. And that's the component that's very difficult to predict. And so what we have seen is that generally speaking, the plume has a narrow form that then widens over time. And we will see that as this current lobe moves through over time, it is going to get wider. So, you know, hence our concern about, you know, the Beacon Knoll portion and additional, while we know which way it's pointing, we know what that width is going to cause problems. So I can't give you a definitive answer for, I don't have that down. We will be installing the additional monitoring wells up in that area so that we can get a little bit closer to that answer. But some of that prediction, especially as it relates to that lateral spreading, is the tough part.
Yep, thank you. I understand. One of the questions that actually I can answer, these are few and far between. There's a handful of questions from folks about the presentations being made available. We will send those out. I want to remind everyone that the webinar is being recorded. And so we will provide a copy of not only the recording of the webinar and a link to that, but also we talked about it beforehand, and I'm going to get a copy of both presentations and share with everyone who registered tonight. Janice or Len, again, one of you, if you could talk about the timing, maybe for the phase 1 and phase 2, the immediate phases for the expansion of the water.
Yeah, I really think that probably is Jim and the Mossville people.
Okay.
Yeah, so.
Yeah, fire away, Jim or Aaron.
I guess I'll take a swing at this. So we've already been through the area doing the survey work. So we have all the survey data, and we've been taking that information and doing kind of like the background modeling and sizing for the water system here. But as of right now, we don't have information from the association in terms of where we would be allowed to put water mains, in terms of easements, right of ways, that kind of stuff. So once we get that information, then we kind of move forward with route planning and have a better idea of, you know, actual timing. If it all got worked out today, I would say we're in planned production and, you know, trying to get this thing going late summer, fall, somewhere in there.
Great, thank you. So there's a question: if if municipal service is run to a home that doesn't have any TCE detections, does the well have to be decommissioned at this time, or could they keep that?
Yeah, if once the home is hooked up to municipal water, yeah, which even though if the infrastructure is out front, you don't have to hook up to municipal water when the system comes through. It's just at that point, the state of Michigan will be paying for your hookup. If you want to hook up at a later date, then the cost will be on your responsibility. Also, if you decide to hook up, your well will be abandoned so that no future contamination from that can be exposure to anybody. And also, if you do hook up to the municipal water, then or if you decide not to hook up to the municipal water, but yet the municipal water is still in front of your home, the state of Michigan will stop sampling the monitoring well or your drinking water well. And the reason why we do that is because we already have provided you a safe drinking water source that we will not keep sampling your private drinking water well at that time.
Great, thank you. Well, I got you, Janice. Is there a concern about gardening in the area? So, you know, uptake of TCE through vegetables, things like that.
No, you know, in this area, especially in the area of the Summit Village Association, the groundwater is very deep. So for it to migrate up, even if it went through the soil gas, like we spoke about the soil gas, it would not be uptake from the into the plants in that area.
Great, thank you. There was a question about the mapper online. Actually, looks like Len might be responding to it right now. Some of the looks like the most recent data on the mapper is 2019. Is that anticipated to be updated with 2020, 2021 current data? How often is that mapper updated?
Sure. So I did just paste into so that you could see it again, an update that gets you into the most up-to-date version of the Plume mapper. Within that, if you click on the TCE plumes, there's a little icon you can shift, and you can actually look, and you'll see that you can look at different TCE plumes from 2020 all the way to 2005. So basically what we do is we take the semi-annual data or we take the data that we collect each year, and we look at the maximum extent of contamination between both the spring event and the fall event, and then create a single compilation map from that. So so those maps are available, and it's updated through 2020. And you can click on each individual one, so you can go back in time and see what it used to look like, because it does change year to year, for sure. And right now we're currently working on the 2021 data, and essentially when we finalize the annual monitoring report, which we anticipate to be completed roughly end of February, at that point the 2021 data gets uploaded into the WebMapper program.
Gotcha, thank you. We do have someone who has raised their hand. So Scott Zimmerman, I'm gonna try and allow you to talk. You may be able to unmute yourself if you want to try and unmute yourself and ask your question.
Hey guys, I'm sorry. How will the federal government's infrastructure bill affect this in any way? Any funding at all?
No, the funding for this site has been the Clean Initiative funding from the 1998 environmental bonds that were used, and that's what we've been using to do the investigations and to extend municipal water. So at this point, the site hasn't received any funding from the federal government.
Thank you.
Great, thank you for your question. There's a question about mitigating TCE at the wellhead. So instead of connecting to municipal water, why can't the TCE be mitigated that way?
Janice, do you want to speak to that one, or do you? I mean,
I was wondering, Matt Remus, in community drinking water. I wonder if that's something that you're more familiar with.
Yeah, I can say typically we don't consider treatment if that's, I think that's what the question is asking, if we could just treat it at the wellhead. We don't consider that long-term solution to providing safe drinking water. That's why we move towards municipal water in this case. Treatment options, I'm not even certain exactly what treatment options would exist, but all those would have to have maintenance. And when you have homes change hands, it's hard to keep an eye on that maintenance. So the safest, best long-term solution in this case is municipal water.
Great, that makes sense. Thank you. Maybe another question then for Jim and or Aaron. We talked about kind of when phase 1, phase 2 are going to get kicked off. Do you have at this time a long-term estimate for phase 4, what that might look like kind of as you build out?
I think Janice might be best for this one.
Yeah,
I keep missing the mark on this one, don't I?
That's okay. That's okay. We sort of commingle. Phase 3 and phase 4 would be in the future if we see that the plume is moving into those areas. So by doing this in this phase approach, we can do the phase 1 and phase 2 right now, and it gives us time to secure some additional money that we'll have available to be able to put the other phases in place if we need them.
And is there, while I got you, Janice, at the original source site, are the concentrations there lessening? Maybe talk about just how that source is kind of operating now.
Yeah, we really don't have a huge source area at the former manufacturing plant back in Mansalona. And if we did, that would be easy. We'd be able to go in and remove it or put some treatment right there. But what we have right now is it's just been leaching, if you want to say, in the groundwater. It's in the groundwater and it's moving on from there. But we just don't have a huge source area still at the plant.
Okay, thank you. And I'm going to keep you right there, Janice.
Okay.
I know you're popular now.
It's okay, I'm in the hot seat.
So a lot of the questions are obviously focused on drinking water. There's a handful here really talking about the vapor intrusion. Is there any kind of one kind of track of questions are what are sort of some of the options? I know Len talked about some of the depressurization systems that were installed. Are you looking at some of those other areas that could be impacted? What are the options for folks that may be impacted by vapor intrusion? And then similar to the mapping software that's out there for the drinking water, is there an opportunity to do some of that? Like, is that on your radar? So kind of two different tracks of questions that we're seeing in the groups here.
Right, and Len can help me out on this too, but we sample many areas from the beginning of where the plant area is all the way out to the toe of the end of the plume for vapor intrusion. So we sample that quarterly out there. So if we see any impacts or any buildings or any structures, such as a school or there's a bigger apartment building in Mansalona, all those areas, they're on our radar. We have points outside of them so that nothing gets impacted. So that's something that we can continue to do, throughout the year.
Yeah, I think the good news to add to that, Janice, is that, in our monitoring, we've really only identified the 3 buildings that have been addressed with subslab depressurization systems as locations where we are have verified that there's a potential concern. So the vapor issue is something for us to continue to watch and make sure we understand. A little more detail we can definitely provide, but so far to date, those are the only 3 locations that have it's a stepwise process. We measure what's in the vapor outside the building, and if we find some issues, we go inside the building and sample below the building. Nothing has even led us to go into other buildings at this stage and go under the building to sample. So that's the good news. It is a scary concept that vapors are going to move into these buildings, but the positive is that we aren't seeing that happening across, except for right across the street from the plant is where that's been the concern. So that's the good news. And the other is that, we do watch this, and there are reports that are available so that if you're concerned about it, you also can see the data that we have.
Great, thank you.
If anybody ever has, I'm sorry, Mike, if anybody has any concerns or questions on that, feel free to reach out to me and I can get you whatever information you need.
Great, thanks, Janice. And maybe what I'll try and do is go back and grab that slide with the contact information and throw that up here in just a second. This might be a question for the health department. I believe we have, is it Casey, I believe, that we have on from the health department. The question is, what is being done to better understand historic exposures and potential health impacts for long-term residents who have been exposed to TCE for years, either through drinking water or vapor intrusion?
Mike, that might be a question. Lisa Quiggle, are you on the line?
Yes, I'm on the line. We've looked into this in the past, and there hasn't been people exposed to the vapor intrusion, except we had a few sites right around the plant. And as far as we understand with the water, you guys are being proactive about it and keeping people's exposure limited by replacing it before people are exposed. So, I mean, I think we were looking at this about 5 years ago, and we really couldn't see that there was continuing exposure in the area.
Okay, thank you very much.
Okay. And the other thing, if they have any follow-up questions, if they could email Janice, I can get back to them too.
Okay, great. Thank you. So I know this was a question that was brought up actually earlier this week, and is being asked again. If the road is being torn up, if there are these construction plans, is there an effort to bring in other utilities that it might be needed in the area, such as natural gas, fiber, other options to bring to the residents as well?
I guess the short answer is no. We don't do any outreach for gas companies or any of that other stuff. But yeah.
Okay. Yep. Thank you. As additional wells are planned to monitor the lateral spread, Len, that was talked about, there's a question specifically about Frog Hollow, close to the Plume, but outside of the area that was discussed. So are there additional wells planned to really address, kind of monitor that lateral spread that you were talking about?
Well, we do have, there are some residential wells that are north of Frog Hollow that are monitored by the health department. And we also have some monitoring wells further to the south. And that spreads, I don't have the map up, but basically that's what we'll be monitoring. But I think that the one thing to keep in mind when you talk about Frog Hollow, which for those of you who may not be as familiar, that's almost due east of the pond at the golf course. So the driving factor right now that really seems to have the greatest influence on the Plume is that section of stream between the pond to the west and Shanty Creek, where so much groundwater is venting. So that's going to be a really controlling component to driving where that Plume goes. So lateral spread further south to Frog Hollow, I think is going to be limited, particularly to the east. So depending on where you are on that site, on Frog Hollow, where your specific concerns are, that might be something else we can talk about as well. If that makes sense.
Yeah, and kind of another general maybe question about just the Plume mechanics. There's a question: as the Plume gets wider, do the concentration levels decrease? If you could kind of hit on that.
Yeah, unfortunately, that's, in a lot of aquifer systems, there's carbon in the system and things like this that can allow the Plume to kind of contaminants within the Plume to desorb or absorb onto the formation, or you may have actually biological breakdown of the chemicals. This aquifer is so sterile, it's so clean without the organics that none of that breakdown occurs. And it's that spreading component that's really about the only thing that's driving the concentrations down over time. So we have it's a unique Plume because there's no smoke and gun super high concentration zone, in the Plume, but it doesn't degrade. And so it's just this lateral spreading. That's about it that brings concentrations over time down. Good question.
Great, thank you. This might be another one for you, so don't go too far, but I've been wrong before. What eventual impact might there be on Lake Belair and the chain of lakes?
Yeah, so currently we feel that everything that we've seen from the Plume suggests that it's really moving strongly towards Shanty Creek. And there's a good chance that it could vent almost like we see at the Cedar River, right there at Shanty Creek. if it goes into the creek particularly, that's flowing water, which helps the TCE move from the surface water to the atmosphere, just like we see at the Cedar River. So that's ultimately, I would have to say is a good thing, right? Especially since the concentrations are below that 200 part per billion threshold that would be detrimental to the aquatic environment. So if a portion of the plume continues on to Lake Bel Air, right now the concentrations that we see again are below that 200 part per billion level. So we don't anticipate a significant ecological impact to Lake Bel Air as well. I guess it's not great news. No one wants contamination to move into our surface water, but there are processes that help break that contamination down in surface water and move it out of the surface water. And right now the levels are such that it doesn't look like it poses a significant ecological threat.
Great, thank you. Who should homeowners contact to discuss the construction plans if they have questions or to understand more about the future construction plans?
Well, I would say, once we have plans developed, they'll be available through, there's usually a set kept at the MOSSA offices or the township hall there. And then, we'll have electronic copies available. We'd be glad to coordinate however it needs to be coordinated. Last time we came into Summit Village, they really had one representative that we were dealing with primarily. So we would give them plans and he can disseminate information to homeowners. Is really ideal so that we're not, dealing with one-off homeowners throughout time, but we would be glad to help however we can.
Great, thank you. While I got you, the Mansalona water supply, is there a treatment facility that MOSSA operates?
No, we use, it's all just like homeowners' wells. We draw it right out of the ground. The only thing we do add is a small amount of chlorine and a small amount of phosphate for lead and copper treatment, and that's it. There's no treatment plant.
Okay, thank you. Janice, kind of thinking out, I know there was a question about any of the federal funding. From a state perspective, there's a kind of a broad question here. What happens when funding runs out to perform some of this ongoing monitoring and some of the other activities that we're performing out here?
I'm going to let Randy Roth take that question. Hopefully, Randy's still.
Hopefully.
Sorry. Technically challenged.
Thanks, Randy.
Yeah, hi, Mike, Janice. The funding mechanism that we have in place right now, we have to ask for funds every year, and that's usually for the following fiscal year. So it can take us up to 2 years before we actually get funding after we request it. If we run out of funds on this project, we don't have any source of income other than the current bond that's out there and some of the money that's coming in through infrastructure and some of the federal funds. We've been lucky so far. We started funding this back, Janice, in what, 2000 or something along those lines, early 2000?
2003.
Yeah, and we've gotten money every year. So we've been really lucky, but people have to understand we compete with thousands of sites of environmental contamination across the state every year for funding. This has always been a priority for Eagle or DEQ. But as long as we have the funding, we're going to keep doing what we're doing. If the money runs out, we may need your help to bug your legislators.
Great, thank you, Randy. We are coming up against the 8 o'clock hour. I do want to be respectful of people's times. One of the things that I think might be helpful as people kind of explore some of the handouts that were provided tonight. The well IDs of the MOSSA supply wells, are those included on the map, or is there a difference? Is there a way that those stand out, or do those look like just the norm, some of the normal other wells that are around? Do you know, Janice?
I thought they were labeled on there as the Cedar River well field, but I'm not sure if they are or not.
I think they say OW for operating well on them.
Maybe that's what it is. Yes.
Okay.
Yeah. So
Okay.
were so.
Okay. And one of the things that I promised Janice was that I would follow up with a question and answer report. So for all the panelists, I'm going to send out a whole report for all the questions that were answered. There's a couple that we didn't get to. I think there's a handful that are still in there that are repeats for the most part. So I think we did a pretty good job of at least addressing most of the things that came in. Again, I want to thank everyone for attending this evening. We will follow up. I'll follow up with a recording and a link to the recording of the webinar tonight, as well as the handouts and the presentations, the slide decks that were given. I will, like I said, give all the panelists the question and answer report. So if there's some that were not answered here tonight, we'll give them an opportunity. We'll try and put together maybe a little FAQ or something to send out to everyone. Again, I really appreciate it. Thanks for spending some of your time this evening. And if you have any questions or any concerns, feel free to reach out to myself, to Janice, to any of the folks that were here this evening. We'll do our best to help you. Janice, any other closing words?
Somebody did ask about their wells being monitored, and they were at Shanty Creek north of the Legend in that area. If they could just give me a call directly, I can work with them with their addresses and we can see if that's something we can do or if it's something they'll have to do themselves.
Okay, great. Yeah, and I will, I'll go ahead and put Janice, I'll volunteer Janice for all that. If you have questions specific about an address, I can vouch for her. She'll help you out. So feel free to, like I said, give any of us a call. We'll do what we can to help at least get answers to your questions. So again, I really appreciate it. I hope you have a great rest of your night and a great rest of your week. Thanks.
Thanks, everybody.